Okay, let's finish. We're going to do one more example. Let's see. Yeah, this is a little different than the first example, so it's probably good to do. So I'm just going to do one more example with a 45, 45, 90, and then we will go to the 30, 60, 90. So this is example 2. And again, you've got a right triangle, and it's a 45, 45. I don't know if that's exactly, if those two sides are exactly equal, but it's close enough. We'll say they are. So they tell you, watch, they don't tell you it's a 45, 45, 90, but they kind of do. All right. So this is an isosceles right triangle. So just knowing those words right there, isosceles, what does it mean to be isosceles? Okay, good. Two sides are equal. All right. So if this is a right angle, these would have to be the ones that were equal because this has to be the larger, correct? So if this is larger, it can't be equal to the other two. Would you agree? All right, so I've got 2. So if I got two sides are equal, what are these angles right here then? Yeah, but what's the degree? 45, okay? So there's 45. So if I told you it's an isosceles right triangle, automatically that makes it a 45, 45, 90 triangle. Agreed? Quick review. You remember what our little, I don't know what you call it, little formula, I guess? The hypotenuse is equal to what? Square root of 2 times one of the legs. Okay, either one of the legs, right? Because both the legs are what? They're equal, right? All right, so this time they tell you, and I think we've kind of already done this, but we'll do it again. They tell you that is 12, and actually, the way I have it written down, they make one side x, the other side y. But what would be true about x and y? They're the same, right? So I'm not even going to write them the same. I'm not going to write them different, x and y. I'm just going to pick one. It doesn't matter what letter you use. I'll just use x. Is that all right? We had a little trick, I guess, if you want to call it that. We had a little way to solve for the leg. We could just use this formula, couldn't we? And plug the stuff in. So what do we know in this situation right here? We know the hypotenuse. So what are you going to put right here? 12 equals what? The square root of 2 times one of the legs. What do we call the leg? X. All right, so now what do we do? Divide by square root of 2. Good. So we kind of already did this yesterday, but we didn't do this exact example, I don't think. So we'll do it. So they cancel out. So x is equal to 12 divided by the square root of 2. Do we circle it and count that as our answer? No. Why not? It's not simplified, right? Why is it not simplified? Where? In the denominator. You can have a square root, okay, and it be simplified, but you can't have a square root in the denominator. Why? I don't really know. Somebody decided way back, who knows when, I don't know the history of it. Maybe other math teachers do, but I don't. But somebody decided we don't want square roots in the denominator. There's some teachers that abide by this, all right, and then they fix it. Some teachers say, it's fine the way it is, all right. But most teachers, I would say, want you to get rid of that square root. So I'll teach you how to do that. Well, I've already taught you. Do you remember what to do? We did it yesterday. Yeah, multiply it by something over something. What is that? Square root of 2, that's right. And there's a reason why we picked square root of 2. Because if I multiplied by 2 over 2, would that get rid of that square root? No. But multiplying it by the square root of 2, not just any square root, okay, the square root of 2, the exact same thing. Because what happens when you multiply a square root by itself? Well, what cancels out? The square root. Because technically, I don't think I showed you this yesterday, but you could look at it two ways, okay? Watch. Here's two ways to look at it. You could say the square root of 2 times the square root of 2 is the square root of what? 4. What's the square root of 4? It's 2. What's the second way you could look at it? If you take a number and multiply it by itself, what are you doing to it? You're squaring it. So really, you're just squaring it, aren't you? So you could look at it either way. So what happens when you square a square root? It cancels it out. What are you left with? You're left with 2. I kind of like to look at it this way, because what if you had a really crazy number? What if you had the square root of 17 and you on the bottom? What would you do? You'd multiply it by the square root of 17. Now, I'm not going to sit there and think, okay, what times, or 17 times 17 is whatever, and then I got a big number, then I got to take the square root of that, right? I don't want to have to go through that hassle. So how would I think about it in my head? I'm thinking square root of 17 what? Squared, and what happens? Without really doing any math at all, right? They cancel out. So what's the square root of 17 times the square root of 17? It's just plain old 17. Everybody got that? All right, that's really very, very important. Again, every once in a while you'll have square roots pop up, especially in this section, all right? Especially with right triangles, because you're using Pythagorean theorem, right? You got squares, and you're going to solve for either A, B, or C, so you're going to have to take the square root. So that happens a lot. It'll kind of die down after a while in geometry, so you probably won't have a ton of it, but when you get into Algebra 2, all right, and I think, I'm not positive, but I think the next section that we're going to do in Algebra 2 does this stuff. Usually an Algebra 2 book will do this very early on, but they wait a while. But anyway, in Algebra 2, eventually, you'll do a lot more with this. All right, so this is a good kind of foundational thing for you. So next year, at least you'll be able to look back. You may not remember every little detail that I do today, but you'll look back and say, oh yeah, I remember doing something like that in Mr. Hammer's class, okay? Yes? Yes, this could be, well, not with a 45-45, because you only are dealing with square root of 2. It's a good question, though, because in the thing that we're going to do next, yeah, there is going to be another square root that we're going to have to deal with, okay? But right now, on a 45-45 is just square root of 2, okay? Now, they could have made this a square root, and it wouldn't have to be a square root of 2. It could have been the square root of 7, or square root of 3 times the square root of 10, or anything, all right? So, yeah, you could have other things, but this right here on a 45-45 is always going to be square root of 2. All right, let's continue with this. I talked too much about this. By the way, let's say one more thing, because I want you to understand not just how to do it, but why you're doing what you're doing. So why did I multiply by the square root of 2 over the square root of 2? Because it's what? Okay, that's one of the reasons. It's the reason why we chose the square root of 2, right? Because it's the same number as that. But why did I do this? Why did I put this over this? It's equal to 1. And what happens when you multiply something by 1? Doesn't change it. Stays the same, right? So the value of x is going to be exactly the same. Would you agree? Because really all I'm doing is multiplying by 1. I was watching a video on something else, but it had this in it, right? And the guy said, well, whatever you do to the top, you do to the bottom. That's not really the rule. Okay, the rule is if I multiply by the top and bottom by the same thing, I'm really multiplying by a 1, right? And you can multiply anything by 1 and it doesn't change the value of it. All right, enough talk. Square root of 2 times square root of 2 in your head now, just in your head, you should be able to figure that out. What is that? It's 2, all right? What's the top? 12 square root of 2. Now are we done? Now do we circle it? No, not quite, but we're almost there. What do you see? Tiffany, you said it. What do you see? What happens here and here? Right, very good. So this 2 divides into 2 once. It divides into 12. How many times? 6 times. So what's my final answer? 6 square root of 2. Okay? So this is 6 square root of 2, and this is 6 square root of 2. Probably went a lot further with this than I really needed to, but I don't know. I just think it's important to see where this stuff comes from. All right, everybody good with that? Now, if you wanted to check to see if it works, let's just do it for fun. All right, let's put this back into, for fun, into the Pythagorean theorem, okay? So what would that be? It would be 6 square root of 2 squared, correct? All right, so make that whole thing squared. That's why I put in parentheses, plus the other one, which is what? 6 square root of 2 squared. And that should equal what? That's my A, my B. It should equal 12 squared. Agreed? Let's see if it does. Can you do this in your head? if I'm going to square both of these things, 6 squared is 36. Square root of 2 squared is 2. 36 times 2, do you know that in your head? 36? Yeah, 72. Good. So that's 72. Plus, that's the exact same thing, right? So that's 72. What's 12 squared? 144. Do they equal 144? It sure does. So it does work, doesn't it? All right. So was this the correct answer? Absolutely. And this is the simplified exact answer. That's what I want you to give me. Unless I specifically say on a quiz or a test, round it to the nearest tenth or the nearest hundredth or something like that, okay? So you're not really using a calculator with this, are you? You can get an answer. I know it's a weird answer. I know if you were doing like some woodworking, or I don't know, or something like that, right, where you had to find what the length of that side was. You don't have anything on your measuring tape, 6 squared to 2. So what would you do? You'd throw it into a calculator and get an approximation, all right? But in a high school math class, we're simplifying like this. Everybody got it? Okay, enough of that. Spent way too much time on that. So now, we did 45, 45, 90. So what did I say we're going to do today? 30, what? 60, 90. Okay? So let's draw one. Again, it may not be exactly to scale, but it'll be good enough. All right, so it's a right triangle. There's my 90. Which one do you think this is right here? 30, right, because this is a smaller one. So that's 30. Obviously, this one right here would be 60. Good, right? What do I call this side right here? The hypotenuse. So I'm still going to call it the hypotenuse. Okay, now I got 2 legs. Now, on the other one, both legs were equal to each other, correct? Because it was 45, because it was isosceles, right? The 2 sides were equal to each other, which makes 45, 45. But this, I call this the short side, and I call this the longer side. But I'll just say long. Is that all right? This technically is the what? Longest. It's the hypotenuse, but it's the longest side. Agreed? So just because I put long there does not mean it's the longest side. Hypotenuse is always the longest side, right? So this is the longer side. Got it? All right, this is the shorter side, or the shortest side. So that's how we're going to look at that. That's pretty easy so far, correct? Now, it's a shorter period today, and I spent too much time on that stuff before. There is a bunch of stuff that I did to show you why the stuff I'm going to write down is true. All right? I don't know if I did it last year. If you're really concerned about it, you can always look at last year's video, and maybe I did it last year. I have it in my notes, so maybe I did, maybe I didn't. But time is of the essence here. Let me see. Remind myself what time. What is it? 1:28? Yeah, we definitely need to move on. All right, so there is a way, and I could show you how we get this, but I don't think you're really going to care, to tell you the truth. You just want to know what it is. All right, so we're going to have 2 things. Remember on the 45, 45, what did we say? Hypotenuse was equal to square root of 2 times one of the legs. But this one deals with hypotenuse, short side, long side. All right, so the first one, and what I'm going to do is I'm going to do a comparison, and they all are going to compare to the short side. So I'm going to do a comparison with the hypotenuse to the short side, and I'm going to do a comparison with the long side to the short side. Okay? So there's 2 things that you have to know here, and here it is. So the hypotenuse is equal to exactly twice the shorter or the short side. So for instance, if the short side was 5, what's the hypotenuse? It's 10. That's right. Because the hypotenuse is twice as big as the short side. Everybody got that? So that was kind of easy. No square roots, right? One's twice as big as the other. That's always nice. So what if the hypotenuse was 12? What would the short side be? It'd be 6. You got it. Super easy so far, correct? The next one's not that bad. But remember, they both compare to the short side. So the hypotenuse is twice as big as the short side. So what do you think I'm going to write down now? The long side, or the longer side, is equal to something. You don't know what the something is yet, but times the what? The short leg, okay, or the short side. All right, they both compare to the short side. If you can remember that, that helps you out a lot. All right, so really the only number that you really have to memorize that you haven't talked about before is this number right here. Now the square, or 2 is the square root of 4. Agreed? Take a wild guess on the number that's just a little bit smaller than the square root of 4. Square root of 3. Okay? And that's what this is. That's kind of how you can remember. 2 is the same thing as the square root of 4. This one, right, because the longer side is not as long as the hypotenuse, correct? It's just a little bit shorter. Would you agree? This is just a little bit shorter than this. The square root of 3 is just a little bit shorter than the square root of 4. All right, that's how I can remember square root of 3. And that is what you're going to use to do these problems. There was a lot of stuff that goes on behind the scenes to get to this. I got it in my notes. See that? It's all right there if you don't believe me. So if I had a whole entire class period and we started right at the beginning with this, I might have gone through that, but we just don't have the time now. So I'll just leave it at that. We good? All right, let's do some examples. That's what you came here for anyway, isn't it? You just came here for the examples. All right, so let's do a right triangle that looks like this. Trying to make that, it looks like a right triangle. There's my right triangle right there. And they tell you that this is 30 degrees. They tell you this is 60 degrees. Of course, that's a right angle. They make this X. They make this Z. And they make this 12. So guess what we're trying to find? Yeah. What are my letters? What are my variables? X and Z, right. The short and the long. It's actually not the long. What is this? What is the Z? It's a hypotenuse. How do you know it's a hypotenuse? It's opposite the right angle. Very good. You give me all good right answers. Okay? So, remember how both of these related to the short side? You see that? Short right here, short right here. So what do you think is the really important side? It's the short side. Okay, the short side is really the one that's super important because they both relate to it. Okay. Since I know the long side, okay, let's use the one with long side. So what's the long side? Long side is equal to square root of 3 times the what? Times the short. Okay. So this is what I'm trying to solve for, the short side, and this is what they tell me. All right, so I just put it into this little formula right here. So what's the long side? It's 12 equals square root of 3 times the short side. What's the short side? It's X. We don't know it, okay? So we put an X. Now the math is pretty much what we did before, isn't it? So we divide by the square root of 3, divide by the square root of 3. Can I go 12 divided by 3 is 4? No, because this is not a 3. I know it looks like a 3, but it's not a 3. What is it? It's the square root of 3, right, which is a completely different number. It's 1 point something. I don't know what it is. All right? But am I going to leave it like that? Am I going to circle that? No, because it's not simplified. How do I simplify that? I got to get rid of that square root on the bottom. How do I get rid of it? Multiply it by itself, right, which is square root of 3. Then I do that to the top as well. Why do I do that? Do I do it just because I always do the same thing on the top and bottom? No, I do it because this red thing right here is a what? Well, it's a what? What does it simplify to? What? It's a 1, right? So I can multiply anything by 1. So let's continue. Let's do the bottom. What's the square root of 3 times square root of 3? Just do it in your head without even thinking. What? It's a square root of 9. All right, but when you look at them, anytime you have a square root times itself, what's your answer? It's just that number. Okay, it's just the number. You got it? So square root of 3 times square root of 3, it's the same thing as going the square root of 3 squared, which means it's the 3. Got it? And how do I write the top? I just write it, I always write the whole number first and then the square root second. So I write it like that. Are we finished? Not quite. Almost there. But 3 does go into 12, doesn't it? Sometimes they don't. All right? You know, if that was a 5, all right, it's not, but let's just pretend. If that was a 5, you would just leave it. 12 square root of 3 over 5. But it's not a 5. It's a 3. So this 3 would do what? Goes into this 4 times. So what's x? 4 square root of 3. And that is your short side, isn't it? So that's important. The short side is important. I'll write it right here since we just found it. Now I got to find the hypotenuse. Well, I have a little thing for the hypotenuse. What's the hypotenuse equal to on a 30, 60, 90 triangle? Right. Double what? The short side. Now I just found the short side. Could I find z by its? Could I find z first? No, because I'd have to find the short side first. Would you agree? All right, before I find z. So I did find the short side, and now I can do this. So the hypotenuse, if you want, we can just put z equals 2 times the short side. So it's 2 times what? 4 square root of 3. Everybody with me on that? All right, so z equals what? 2 times 4 is 8. So I can multiply those together, can I? Because they're just regular whole numbers or integer numbers. So I can multiply those together to get 8. What do I do with that square root of 3? Just stick it right next to it, okay? I can't go 8 times 3 is 24. Everybody understand that? It's a common mistake people make when they first learn square root stuff. All right, but that's it. That's my answer, 8 square root of 3. Is 8 square root of 3 twice as big as 4 square root of 3? Absolutely, right? Because 8's twice as big as 4. Make sense? Yeah. So that's really not much different than the 45-45, is it? It's just 2 things you got to remember, though. 2 different things. If I had the square root of 3, what? Divided by 5? Times 5 like this? Okay. Oh, just a regular 5? Like times 5? Then what I would do is I'd always put the whole number out in front. That's what we usually do. Now, would it be wrong to write it like that? It wouldn't be wrong. It just doesn't look right. Okay, this looks right. Okay? And, you know, we want to write things the same so everybody, when they see it, like, okay, I know what that means. All right, but that, I mean, if you wrote your answer, like, if your answer was this, like right here, I mean, you could write square root of 3 times 8, but again, that looks weird to me. I always want that whole number out in front. This looks normal, okay? So it would be better to write it like this, much better. Make sense? All right, let's do another one. Let's see, make sure I cover everything. Yep, did that. Yeah, we got just, oh, now, that was the only example they gave for 30, 60, 90, okay? And that's probably the hardest version. When they don't give you the short side, that's usually the hardest version of these problems. When they give you the short side, it's super easy to find the other 2, right? If they give you the short side, how do you find the hypotenuse? Just multiply by 2. How do you find the longer side? Just multiply by the square root of 3. But when they don't give you the short side, that's the part where you got to do all this stuff. All right, enough of that. Let me teach you one more thing. What is this whole chapter about? Nah, the chapter itself. No, the chapter. The chapter, not the section. Area, right, area, isn't it? And the whole chapter about area? We haven't done any area in a while, have we? Pythagorean theorem, we didn't do it. 30, 60, 90, 45, 45, 90, we didn't really do anything, but now we're going to do it. All right, we're going to do some more areas. So let me draw a triangle here, and it's going to be an equilateral triangle. What does that mean, to be equilateral? All the sides are equal. Very good. Somebody's listening. That's great. All right. It's equilateral. So that side is 5. And I think no, it's not 5. Don't put 5. Sorry. That's the example. I'm not doing the example yet. Sorry. This is one of our sides. So that's a side. That's a side. That's a side. Kind of looks like 5, doesn't it? But those are my sides. What I want to do is come up with a little formula for the area of an equilateral triangle. Okay? You could probably do this without this formula, but sometimes a formula is nice. So what I'm going to do, 28 after, yeah, let's try it. Let's give it a shot. Just gonna, seems like I always run out of time. I want to come up with this formula. So what is the area of a triangle? Area of a triangle is base times height divided by 2, correct? Or you could write it 1/2 the base times the height. So let's come up with a formula that we can use here. When you have an equilateral triangle. So if it's equilateral, it means it's equiangular. So this angle must be 60 degrees, right? What's this top angle right here, this little one? That must be 30 degrees. Well, the whole thing would be 60, but that one right there would be 30 degrees. Agree with that? What about this side right here? What about from here to here? What would that length be? The length of a side. Half of the side, right? Or 1/2 what? S, because S is the side. All right? You with me on that? Okay, so now, let's see, what did I do? Oh, okay. So look, I got a 30, 60, 90 triangle. I have my short side. That's the short side. Okay, I can find the other two things, can't I? What's this side going to be? Well, it's going to be 5, okay, because they're all the same. Sorry about that. What about the height, though? That's the key. What's the height of this? Remember, this is the long side, right? So the long side is equal to what? No. The long side is equal to what of the short side? The square root of 3, right? So it's going to be the square root of 3 times what? 1/2 S, or just write it like this, S over 2. And that's the same thing as 1/2 S. So what's the height of this thing? It's square root of 3S over 2, correct? So let's do this. The area of the triangle, let's write it with all this stuff. So I know the height, I know the base, and let's figure out what that is. So it's 1/2 the base. What's the base? 1/2 S, correct? That's our base. Oh, I'm sorry. It's not 1/2. Because the long side is the square root of 3 times the short leg. Remember the long? We just talked about it. Is square root of 3 times the short. So the short is S over 2, right? And so the long is the square root of 3 times S over 2. That's how I wrote it right there. So let's find the area of this whole entire triangle now. So it's 1/2 the base. What's the base of the whole triangle? It's just S, isn't it? Right? That's the base of the whole entire triangle. All right, so that's 1/2 the base times the height. What's the height? Square root of 3 over 2 times what? Times S. This is a triangle. Area of a triangle. This is not any triangle, though. This is the area of a equilateral triangle. All right, all that said, let's simplify this. What do I get? Well, I got a 2 on the bottom and a 2 on the bottom, and I got an S and an S. So what does that give us? I got a square root of 3 on the top, correct? 2 times 2 on the bottom, which is a 4, Then I got a s times s, which is s squared. So there we go. There's a little formula for the area of an equilateral triangle. So that's something that might be nice to be memorized. To tell you the truth, I probably don't have that memorized. Okay? If you would have stood here before I did this and said, what's the area of an equilateral triangle? I doubt I could have told you that. But I still could find it by doing all this stuff and finding that to be 30, that to be 60. So you don't really have to have this memorized. You could always put the numbers in, right, and just work it out and not have that memorized. But sometimes it's nice to have it memorized. All right, let's do an example. We'll be done. The bell, I know the bell's about to ring any minute here. So let me do this again. So again, here's an equilateral. Now this only works with equilateral triangles, only if the triangle's equilateral. So let's do the fives this time. So that's a 5, that's a 5, that's a 5, and they ask you to find the area. What is the area of this triangle? Now you could do all this stuff. You could drop that down, make that 60, make that 30, take half of this, which would be 5 over 2. You could do all that and it'd be perfectly fine. But we did come up with a little formula. So what is our formula for an equilateral triangle? It's the square root of 3 over 4 times the sides squared. So now let's do it. Area equals square root of 3 over 4 times the sides squared. What would that number be? That'd be 5 what? Squared. So what do I have? 25 square root of 3, what? Over 4. And that would be the area. Let's say it's in inches. Okay, what would this be? Inches what? Squared. And there you go. So if you know the formula, it's pretty easy. All you got to know is one of the sides. Just plug it into our formula, and bam, you got the area. Now, it's a weird number. This is not a number that we would use if we were actually trying to find the area of something, but how could you find an actual number? I mean, this is an actual number, but a number that you could measure. What would you do? Put it into a calculator, get a decimal. Exactly right. Okay? All right, yeah, you're going to do the rest, which is 19 to 32. All right, and you should be able to, whatever you couldn't do for 1 to 16, you should be able to do now. Okay? So finish 1 through 16. All right, finish that. So this is part A. This is part B. I'll take them as 2 separate assignments, okay? Everybody good? All right. This is section 7-4. I guess the bell's not ringing. Wednesday, yeah, this class, for some reason, it doesn't do that.